Hello, good morning or afternoon. This is chapter 3, at least the first few pages of chapter 3, and we jump straight into the theory after having learned some concepts about macro statistics. So, national income, where it comes from and where it goes. So, in chapter 3 and chapter 4, we will discuss what's called a long run or classical model. This is the first macroeconomic model that we'll be discussing and learning. And you'll see it's quite straightforward, fairly easy, and there's a lot of simplification happening, which we all should be aware of. All right. So, first, we've got GDP. And one of the important questions is how is GDP determined according to the economic model we're about to study? Okay. And recall that GDP is the value of economic activity. So the value of economic activity, where does that inherently come from? All right. So here are our questions. How much do the firms in the economy produce? What determines a nation's total income? Because it's GDP, total income is also total expenditure. And then out of the total or national income, who gets that income? Okay. How much goes to compensate workers and how much goes to compensate owners of capital? Those are our two types of inputs into production, right? Workers or labor and capital. Who buys the output? So how much do households purchase for consumption and how much do households and firms purchase for investment? And how much does the government buy for public purposes? So you'll notice that this third bullet is all about the expenditure side, C, I, and G, right? Which of the Y, how is the Y divided between labor and capital? That's the second bullet. And the third bullet is about how is Y divided into C, I, and G. Then finally, what equilibrates the demand for and supply of goods and services? So you can think of GDP, which is Y equals C plus I plus G, as an equilibrium condition, where the left-hand side, the Y is the total output, and the right-hand side is the total expenditure, C, I, and G. All right. So before we get cracking on those questions, let's remind ourselves of the circular flow diagram, of which this is the example. So this example is a more realistic version. I'm reading through the uh, caption of the circular flow diagram found in chapter 2. Each yellow box represents an economic actor. So now you've got households, the government, and then firms. Each blue box represents a type of market. So you've got the market for factors of production, you've got financial markets, and you've got the market for goods and services. The green arrows show the flow of dollars among economic actors through the three types of markets. So let's examine that. So, like before, firms to households, factor payments turns into income, okay, to households, meaning the firms pay wages and rent for their capital. And in the market for factors of production, they pay the inputs, capital and labor, and that becomes their income. And that income goes to the households. Meanwhile, the households decide how much to spend in the markets for goods and services, and their spending turns into revenue for firms. Okay, so this outer circle is basically the same circular flow diagram that we saw earlier with the simplified example with one output of bread. So now we're allowing generally for an entire market where you've got different products and different firms and different households. One key difference is the middle part here. So now we've got the government here, which households will pay taxes, and then the government will decide to spend some of it and will decide to save some of it. Okay. To the extent that the government spends it, it will turn into G, right? Government spend expenditure. And that will combine between consumption, G, and then I, which we'll talk about in a moment, to turn into essentially C plus I plus G, or the expenditure side of GDP. Now, finally, you've got financial markets here. Financial markets are about combining private saving and public saving into investment, right? So that's what a financial market is. Funds that are not spent today and therefore are saved either from households or from the government, they're set aside, right? And then financial markets are all about reinvesting this money into well, as we all know, we know what investment stands for. It means spending on capital goods or goods that will help you produce goods in the future, right? So what this is doing is you're saving or putting aside all of the savings, public and private saving, and then it's going to be funneled into financial markets where it's going to be turned into investment expenditure, right? Um, and the investment expenditure is the third type of expenditure that makes up GDP, because that will be consumption, government purchases, government spending, and investment. Okay. And all three of that will need to be equated to total output Y, or total income Y. Right. So there's going to be an equilibrium mechanism happening to make sure that total income will equal total expenditure. Okay. So notice again what's happening, right? In the macro statistics, we said that total income equals total expenditure by definition. And that's how we compute for it, right? And one of the reasons that's the way we compute for it is because it's coming from a model or an economic framework, wherein in that economic framework or model, total income or Y will become equal to C plus I plus G through a mechanism which we will elaborate in this chapter and in other chapters as well. Okay. So there is the accounting reason why Y equals C plus I plus G, which is what we had talked about in the previous chapters. And now, since we're doing economics, there's going to be this economic model that underpins the equality between income and expenditure. Okay, so please read through most of this. So this will, of course, come into play later on. Now let's talk about what determines the total production of goods and services, right? What determines why? Okay, this is what determines why. So this is the total production of goods and services. So you can think about this in terms of a demand and supply model, where the total production of goods and services, that's the supply of goods and services, right? Okay. The variable you should be thinking about here is Y, right? Y, or GDP. Now, factors of production is the next topic. How do you produce our GDP? Well, you use factors of production, or more specifically, factors of production are used to produce GDP. So, what are our factors of production? The first, we've got capital. Capital is a set of tools that workers use to help them make products, right? The construction worker's crane, the accountant's calculator, an author's personal computer. Labor is the time people spend working. We use K to denote capital and the symbol L to denote labor. Okay. So in this chapter, we take the economy's factors of production as given. In other words, we have a fixed amount of capital K and a fixed amount of labor L. So our K is equal to K bar, which is some value, and our L will be equal to L bar, which will be some value. And that's what the over bar means, that each variable will be fixed at some level. We also assume here that all factors are fully utilized and no resources are wasted. So again, in the real world, part of the labor force is unemployed. So here, L is the labor force. And some capital will remain unused. But in this one, we will assume that we'll set aside unemployment, we will set aside unused or underutilized capital, and we will say that L and K are practically fully utilized. K and L are almost all working or used, if not all. Now, here's our production function, right? Our GDP, which happens to be our amount of output Y, is going to be affected by capital and labor. Here. So the amount of inputs you have will produce a given amount of outputs Y. Okay. This equation states that output is a function of the amount of capital and the amount of labor. Okay. So the production function represents the available technology for turning capital and labor into output. If someone invents a better way to produce a good, the result is more output from the same amounts of capital and labor. Thus, technological change alters the production function, right? So changes in the ability to produce output from a given set of inputs that will tend to increase Y for a given K and L. Many production functions, including the ones we will study and learn in this class, will have what's called constant returns to scale. So a production function with constant returns to scale means if an increase of an equal percentage in all factors of production causes an increase in output of the same percentage. So if the production function has constant returns to scale, then we get 10% more output when both capital and labor rises by 10%. So mathematically, a production function has constant returns to scale if this equation is true, and z is just some positive number z. So you can play around with this concept, right? The same interpretation in the text is also apparent here. So let's say z is some number like 2. This means that if you double capital and then you double labor, your output will also be double, right? So for any positive number z, that will be the case. Now, if you have 10 times of k and 10 times L, your y will also be 10 times larger. This comes from the notion of replicability. So here's the example of replicability here. So let's say that you have a business, this bakery. You have a given number of capital and a given number of labor, and that produces a given number of y. And what if you just doubled it? You doubled everything that's involved in making that Y. You doubled the number of ovens, you doubled the number of workers, you doubled the number of stores, etc. Then if you doubled everything, that's as if you had multiplied it with Z equal to 2. And that means your output should also go up by 2. All right. Now, in this model here, if you'll recall, K and L are both fixed, K bar and L bar. And there's no wastage. So the entire K and the entire L is going to be used in the production function, right? In that case, your output is also given, right? Because your Y now is a function of K bar and L bar. And since K bar and L bar are fixed, so is your Y. Okay. And that's your Y bar. So I think we have a picture of here, the production function. So we'll jump to the production function here. And this is the production function that we'll be looking at. And if you'll notice that it's going up, right? The higher the labor is for a given K bar, the more output you produce. Okay. So right now I'm going to replicate this curve. And if you come with me here, if you'll notice, here you've got an upward moving curve here with labor in the x-axis and output in the y-axis. Note that we have as fixed as part of the function here k bar. Okay, so any given k bar will have this kind of shape. Okay, and then since L bar and k bar are fixed, total output is in fact also fixed at y bar. Okay. So these lines here, left side and on the right side, these are hypothetical L's, right? For a given K bar, if we change the L, if we made it higher, your output will go up here. And if we went down, if your L went down, it will go down, if you can see. Okay. And this is basically where we're at. Okay. Again, L and K, they're fixed at K bar and L bar, which means your Y bar is fixed and your output is represented by this, where the L bar here intersects the output function at a given K bar. And that's your Y bar. Some of the things we discussed. If everything goes up by a certain amount, by a certain Z, then many things will change here in this picture. This L line will move up by Z. This whole thing will also move up. And it will move up because K is moving here. And that's why this whole thing will go up as well. For any L, since K is increased by Z, then F, a function of L, will go up because K bar has gone up. How much will it go up? Well, the new intersection then, well, let's try to make this out. So let's say you had a new L here, so on. Okay. Let's say that increase in L is, let's make up a number, 1.1. Let's say this is an increase in 1.1. Let us now put in insert text box. Where here, L tilde, L prime, equals 1.1 L. Should be L bar. So I'm just going to copy this L bar here. 1.1 star L bar, right? So now this is your new L, which we will call L bar, right? Now K will also move up to the new one. Therefore, this will become not K bar, but L prime, which is basically the same as 1.1 star, and copy this again, K bar. There. And there's going to be a new curve, which is shifted up. And I'm just going to do it this way. Okay. Correct? All right. Now the big question is, how much will it shift up? Oh, first let's give it a new color. So we need to make sure that we all see. Let's do orange, the new one, and then let's change the text color here to this one, right? How much will it shift up? Well, we know because they're all shifting up by the same amount, 1.1 in K and 1.1 in L. Therefore, your Y here should also be shifting up. I'm just gonna get this out of the way. This one will be shifting up also by 1.1. And let's assume that it's this one. And in particular here, what we've got will be y prime, sorry, y prime, which will be 1.1 times y bar, right? There. And that's how much the production function will shift up by. Okay? Because we know from constant returns to scale that if we increase L by 1.1 and we increase K by 1.1, therefore your Y should go up by 1.1. All right. So that's constant returns to scale. Where are we? Okay, that's constant returns to scale, and that's Y bar as well. Now the next question is how is national income distributed to the factors of production? So to examine this, long story short, we're going to use markets. Okay. So it's based on this modern theory of how national income is divided amongst the national factors of production is based on this idea that markets where prices adjust to supply to balance supply and demand. Okay. Here, those prices are the input prices called wages and rents, and they're applied to the markets for the factors of production, K and L. So let's do it. So here are your factor prices. The distribution of national income is determined by these factor prices. Factor prices are the amounts paid to the factors of production, and they are essentially what workers earn. We call that wage. Okay, that's the price for workers, wage. And rent will be the counterpart of wage for capital owners. Okay. The price of each factor of production receives for its services is in turn determined by the supply and demand for that factor. So, like in the microeconomics you're doing now, we will turn to drawing a supply and demand for our products, right? Because we have assumed that the economy's factors of production are fixed, the factor supply curve in 3.-2 is vertical. Regardless of the factor price, the quantity of the factor supplied to the market is the same. Okay. The intersection of the downward sloping factor demand curve and the vertical supply curve determines the equilibrium factor price. So in fact, this here is our drawing. So the simplest one to consider Here we have this, the marginal product output. Ignore this one first, right? But the easiest one to consider on the supply side, the easiest curve to consider is the supply side because it's essentially a vertical line like so. And you might ask why it's a vertical line? Because it's a vertical line because we've got L bar, which is, where's bar? This one. And this is L bar. Okay. So recall that L bar is some number that's fixed and all labor is consumed. So L bar is here. And that's why the supply of labor is essentially a vertical line. All right. Yeah. And which explains why this is the case. So this is in fact L bar, or in Capital's case, it's going to be K bar. Now, the big thing here is what is this factor demand? So the price paid for any factor of production depends on supply and demand for the factor services. Because we have assumed that supply is fixed, the supply curve is vertical. This downward sloping demand for labor, we have a downward sloping demand for labor and a downward sloping demand for capital as well. And the intersection of the factor demand and factor supply will give you equilibrium factor prices, which is either W for labor or R for capital. So next, we have to examine and understand the demand for the factors of production. Okay. So supply, very easy, but now we have to think about demand. So this section is all about how to understand the demand for labor. The simplest assumption to make about a typical firm is it's competitive. Competitive firm is small relative to the markets in which it trades, so it has a little influence on market prices, the prices at which it sells. For instance, our firm sells a good, produces a good, and sells it at the market price. Because many firms produce this good, our firm can sell as much as it wants without causing the price of the good to fall, or it can stop selling altogether without causing the price of the good to rise. Okay. Similarly, our firm cannot influence the wages of the workers it employs because many other local firms also employ workers. The firm has no reason to pay more than the market wage, and if it tried to pay less, the workers would take their jobs elsewhere. Okay. So in other words, let's write it down here. Insert this text box. Firms cannot affect selling price P, and they cannot affect input prices W and R. Okay. This is called the perfectly competitive assumption, or the competitive firm assumption at the output and in the input side. To make a product, the firm needs two factors, capital and labor. Okay, similar to the aggregate production function. So we represent a firm's production function with a production function similar to that of the entire macroeconomy. Where now Y is the number of units produced, which is the output for the firm. K is the capital of each firm, and then L is the number of labor hours worked by the employees of the firm. Okay. This F is also constant returns to scale, and it's also holding constant technology as you're changing K and L. So notice firm level has the same production function with each other. So this here with each other, and thus with the macroeconomy itself. So, and that happens to be F as a function of K, L, and K, or K and L. It doesn't really matter. So we'll talk about this as firms. Okay. Now, the goal of the firm is to maximize profit. Profit is equal to revenue minus cost, and that's this one. Profit is revenue, P times Y, minus WL, which is labor costs, and which is capital cost. And so we'll write that down. Each firm will max profits, which are profits equals P times F of L of K, here L of K, which is Y, minus W and L, minus R and K. Okay, and that's your profit. The profit equation shows, oh, hold on. So reminder, the firm cannot affect P, W, and R. The firm will choose L and K. Okay. To, while not affecting P, W, and R. Okay. So this equation shows that profit depends on the price P and W and R and L and K. But the competitive firm takes P, W, and R as given, and then it just maximizes, or it's allowed to change and choose the optimal L and the optimal K to maximize profit here. So what is the firm's demand for factors? So the first big concept here is what's called the marginal product of labor. So what is the marginal product of labor? The marginal product of labor is when you increase labor by 1 unit, how much will your output grow by? So if you notice here, you've got f of k with L plus 1, and then you subtract out L with k and L without the plus 1. So literally, you're adding a 1, and what happens to your y? And the change in y is equal to your marginal product of labor. How much extra output or y are you going to produce if you increase your labor by 1 unit? So production functions will have this property, which is called diminishing marginal product. We have diminishing marginal product of capital and labor. Okay, so what is that? Diminishing marginal product. So if you notice here, this is the marginal product. And something that's diminishing, that means this marginal product is falling. Okay, as you're increasing L, your MPL itself will be falling. Okay, so that's why it's called diminishing marginal product. Okay. So the intuition is here in this paragraph, right? Holding the amount of capital fixed. The marginal product of labor decreases as the amount of labor increases. Consider production of bread in the bakery. As the bakery hires more and more labor, it produces more bread. The MPL is the amount of extra bread produced when an extra unit of labor is hired. As more labor is added to a fixed amount of capital, the MPL falls. Fewer additional loaves are produced. Why? Because workers are less productive when the kitchen is more crowded, when more people are using the same capital and the same space, etc. Right? In other words, holding the size of the kitchen fixed and the capital stock within the kitchen fixed, each additional worker will increase output by only a little bit. In fact, you can imagine, for instance, that the marginal product will turn negative at some point because literally it's just adding more congestion and it's not working out, right? So from the marginal product of labor to labor demand, when the competitive profit maximizing firm is deciding whether to hire an additional unit of labor, it considers how using that decision would impact profits. Okay. It therefore compares the extra revenue from increased production with the extra cost of higher spending on wages. Okay. The increase in revenue from an additional unit of labor depends on two variables, the marginal product of labor and the price of output. Okay. So the change in revenue here depends on the price of output and the marginal product of labor. Because as you increase labor, your output goes up by this much and your revenue should go up by that much as well. Okay. Now, the extra revenue will be price times MPL. So the reason why it's price times MPL is because the firm has no control over P, right? No matter how much it sells, P will be the same. In particular, if you decide to increase L by 1, the price will still be the same. So the price times MPL, that's just the extra revenue you will get after you decide to produce one more unit. Okay. So this is the increase in revenue, price times marginal product of labor. So before we continue, let's return here to make sure we understand the marginal product of labor concept, right? So again, we're moving from L bar. Let's pretend we're starting at L bar. And then let's say that we are able to increase the total amount of labor in the macroeconomy from L bar to L prime. And that means increasing it by 1.1. So if you increase it by 1.1, but you don't change the KL, not the KL, the K bar, I should say. You don't change the K bar. And that means you're just moving along this original dark blue line here. So the change in Y will not be the whole thing here, right? Will not be this big gap here, but will just be the smaller one here. Okay? And this new Y, I'm going to call this Y plus 1. Okay. Y star star. I'm going to call it Y star star. This Y star star here, it's going to be bigger than Y bar because you increased labor, but you never increased capital, right? So this is what marginal product of labor is, right? The increase in Y stemming from an increase in one of the factors, but not the other one. So in this case, I'm going to draw or insert this shape here, this one, and I'm going to say like this. And this one, I'm going to extend it briefly here. So the gap between Y star and Y bar, this gap that we're talking about right now, is Y star star minus Y bar. And that's going to be equal to MPL, or the marginal product of labor. Okay? This difference here between, oops, the bar went away. Let's copy the whole thing. There. This Y star star minus Y bar, that's the marginal product of labor. All right, so now that's P times marginal product of labor, right? You increased your output or your labor unit by 1, then your output goes up by MPL, then you multiply it with how much you're selling it for, and that's your increase in revenue. Your cost, though, will go up by W because you increased your L by 1, and every time you increase your labor force by 1, you pay an additional W pesos for that, okay? And therefore, if you rearrange this, the change in profit has to be 0 to maximize it, meaning you increase your L such that the increase in revenue just equals the increase in cost. And that's what maximization is all about. And therefore, the competitor firm will set their output here. Let's look for the text box. The competitive firm will set P times MPL equal to W, and this will maximize your output. Oh, no, not yeah, maximize your profit, sorry, which will maximize maximize profits. Because here, it's basically marginal revenue. The interpretation of this is marginal revenue equals marginal cost of increasing output. Okay. All right. Now, in fact, this downward sloping line that we have here, and this is where we will end, this downward sloping line here, this is in fact price times marginal product of labor. Okay? Price times marginal product of labor. And that's how we get this downward sloping line here at the national economy level. So this price equals MPL. This is going to be the national or macro level demand for labor here. So in the end, we will end up with something like this, a downward sloping demand for labor that will come from the fact that the MPL itself is downward sloping when it comes to labor. And you can do the same graph here by replacing the marginal product of output with respect to capital instead. So instead of L bar, you have K bar. Instead of L down here, you can make it K. And this downward sloping line will be the price times marginal product of capital. All right, so that's where we'll end. The next video will continue with the discussion. Thank you.